In this video, we're going to be covering a little bit about the project that I want you to work on this week, using the Arduino and building a gearbox and driving a stepper motor. All right, so first of all, here is a picture or a video of my gearbox. So you see I have several gears, and let's start with here's the stepper motor. All right, so you can pull that from your kit. And I used some machine screws like we had for the truss project. You may be out of those. You might need something like that. But just go get some machine screws and you can mount that stepper motor to this to these pegboard looking things to support your gearbox. It turns out that for my set of gears, the pink and the blue gears fit right on the shaft of the stepper motor. Okay, what are the odds that would work out so well? All right, so that's what I'm expecting to use. Initially, we were going to use a different motor, but I switched it to stepper motors because that happens to fit so well. And there's several things about the stepper motor that I like, and so we're going to use that instead. All right, so you notice also that I use machine screws to secure the supports for the gearbox. All right, so again, you might need some machine screws that are long enough to go through the board and give you a little space to make a gearbox. All right, so let's look at the Arduino. The Arduino, of course, is connected to the computer mainly because it needs power. If I had an alternate power source, you could plug in there and it would still work because I've already loaded the code onto the board. The next thing I have is a little infrared reader, and there's some code that goes with that in the Arduino IDE, okay? And what that does is it lets me use this remote control to control the stepper motor, all right? Another important thing that you need to do is you need to hook up the external power supply that is used to drive the stepper motor, okay? So the stepper motor needs power, and it also needs a stepper motor controller. All right, so here is the stepper motor controller that comes with the kit, and it's generating the signals that help run the stepper motor. I'll give you a separate video on exactly what's happening with that. Okay, the thing I wanted to warn you about is when you zoom in close here, the plus and the minus, you see the plus and the minus here, are reversed from the proto board. Okay, so the proto board, normally the blue strip is the minus and the red strip is the plus, but really those are just wires, all right? So when you plug in this power board or this power supply into the proto board, the wires end up being reversed. So you need to watch that or else you'll end up shorting something, okay? All right, so there we are with that. Okay, the next thing I wanted to show you is the way I have this geared. All right, so I have a big gear, the big pink gear with 50 teeth, that's driving a small gear with 10 teeth. All right, so you can see that right here. All right, now this is a compound gear because the small gear and the other pink gear are on the same shaft. All right, and from there, the pink gear is driving yet another small gear. So this is really geared for speed, all right? And because of that, it's giving up a lot of torque. All right, so what I have shown here is a string, and when I press the appropriate button on the infrared remote, okay, so I'm gonna press the volume button on the infrared remote, what you'll see is the string winds up. Okay, see it winding? And you can see the end of the string. I have no load on here, all right, because this doesn't have a lot of torque, all right? And so, in fact, if I hook up just a little bit of weight on this, I can bring this to a screeching halt because it didn't have enough torque to lift it up. All right, my prediction was that I'd be able to lift about 3/4 of an ounce, and that turned out to be almost exactly true. All right, so you can go through some calculations that let you predict how much weight you should be able to lift. All right, so this is geared for speed. I got a big gear connected to a small gear and then a compound shaft with another big gear connected to a small gear. So the gear ratios work out that I'm going to generate as much speed as I can from this slow moving stepper motor. So the stepper motor only rotates, I think I read somewhere it's 13 RPM, so it's pretty slow. All right, but I geared this to lift things faster. Okay, the other thing about a stepper motor is that you can control exactly how many rotations that you want to have, or even partial rotation, because it has steps in it, and you can program the number of steps that are going to be taken. So I have this program to where when I press the button 1 on the remote, so I'll do that now, it doesn't lift the string. I must have pressed the wrong button. Press the 1. Let me rewind it first. Okay, I have this program where I press the 1 on the remote, it doesn't do as many revolutions, okay? And so it lifts it a certain distance. You can calculate that distance based on, you know, the geometry of the gearbox and number of revolutions, all that sort of thing. Okay, so that's one of the things I'm going to want you to be able to do, is to program different buttons on the remote to lift your load different heights. Okay, so that's a quick walkthrough for one of the gearboxes that I built. I'll do another video for a second gearbox.